Here's problem 1420. The water level in the reservoir is maintained at a constant level. What is the exit velocity of an outlet pipe 3 meters below the water surface? Alright, so we have some kind of reservoir, and there's an outlet pipe from this reservoir, and so we have water level inside, and out of this pipe comes some water, and this pipe is 3 meters below the surface of the water. So bearing down at the top of this reservoir is atmospheric pressure equal to 1 atmosphere. And there's also atmospheric pressure at the opening here, so that's 1 atmosphere as well. So we're going to apply Bernoulli's equation to this fluid. We have point A at the top of the reservoir and point B at the opening there, and we can define our height at point B as being 0. So our height at point A is indeed just h, or the 3 meters. So as we apply Bernoulli's equation, we have that the pressure at A, absolute pressure at A, plus 1/2 the density times the velocity at A squared, plus the density times g times the height at A, should be a constant. So that is the pressure at B plus 1/2 the density times the velocity at B squared, plus the density times g times the height at B. Well, we define the height at B to be 0. That's our lowest height. That would make the height at A just simply equal to h. We know that the absolute pressure at A is atmospheric pressure, and the same thing at B. So those are going to cancel out because they are the same. And our reservoir is really not moving that fast, even if we have flow through this hole. So the velocity of the fluid at point A is really minimal, basically 0. So our velocity at point A is basically 0, so that term is going to be gone. So what we're left with is rho gh is equal to 1/2 rho velocity of B squared. Density will cancel out on both sides of this, and we're solving for the velocity of B is equal to the square root of 2gh. Sounds good, just like in potential energy for a mass. So this is going to be 2 times 9.8 times 3 meters square root, and that is equal to 7.67 meters per second. So that is the outflow through the pipe. It's 3 meters below the top of the reservoir, 7.67 meters per second.